Has this ever happened to you? You're trying to search something on your phone, but you're annoyed because the touchscreen isn't working and you're starting to get frustrated. Then you remember that your phone is from 2013, so maybe it's time that you get a new one. You want to get rid of it, so you try to throw it out. Then you remember, wait, phones don't belong in the trash. They're hazardous waste. So instead you want to recycle it. But you can't just put it in a single stream recycling because, again, phones are hazardous waste. You think you might drop it off in an e-waste recycling facility, but before you do that, let me ruin your day with some fast facts about e-waste recycling. Phones can't be thrown in the normal recycling because they're toxic and they contain many materials, so they must be sent to a specialized facility, which sounds great, or at least okay. After all, it's specialized. But recycling is not a public service, it's a business. And rich countries just want to get rid of their e-waste because it's not worth anything to them. So it's shipped off, oftentimes illegally, disguised as donations. It can have adverse health effects on the populace of the receiving country. In many cases, recycling smartphones may consist of burning, crushing, or acid bath. Though in the case of smartphones, recycling unfortunately really means just sending our trash elsewhere. Nowhere is this more true than in Guyu, China. A city that employs 60,000 e-waste workers receives 100 truckloads of e-waste daily, and as a direct result has elevated levels of heavy metal poisoning. We could just put it in a drawer and forget about it. Or we could try something else. Reusing these old phones as compute notes to extend their lifetime.
Hi everyone, my name is Subhash and this is my second quarter at UCSD as a master's student in computer science. In this project, I mainly worked on the Raspberry Pi side, handling the job scheduling between the phones and also the communication between the phones and the Raspberry Pi.
Hello, I'm Eric and I'm a third year graduating with a BS in computer engineering. For this project, I worked on developing the Raspberry Pi controller code, the logic for powering on and off the phone, working with integrating the socket I/O server, and the logic for mishandling misbehaving phones.
Hello everyone, my name is Ruo Han. I'm a first year master student. I mainly work on the phone side, especially the communication between the phone and the Raspberry Pi.
I'm Emmanuel, and this is my last quarter at UCSD. I will be graduating with a bachelor's degree in mathematics and computer science. I worked on designing and assembling the case, as well as benchmarking the phones.
And I'm Jen, a first-year PhD student. I worked on mobile OS-related issues, as well as integration. To build our data center, we first acquired several old phones from donations and from ordering them online from eBay. Replaced the Android OS on these phones with Ubuntu Touch, an open source OS that is a flavor of Ubuntu for mobile devices. This allowed us to run arbitrary code on the phones and also let us avoid several problems related to mobile OSs, such as their tendency to kill long-running tasks in the name of power management. We added Wise smart plugs for power management, which let us toggle power on and off to the phones remotely to ensure that our phones are not plugged in too often because that can lead to battery decline. We added a Raspberry Pi to control everything and then we were good to go. We did several benchmarking tests of our phone and our complete data center, and then we put everything into our 3D printed box, which includes a fan for cooling. In this demo, we have 3 phones connected to our data center, and the first thing I'm going to do is go ahead and register all 3 of the phones with the Pi. So now I've done that and I can submit a job. I submit 2 jobs in quick succession. The first one is allocated to the third phone, and the second job is allocated to the first phone. They start working away on their jobs, but meanwhile I'm going to simulate a failure by turning off the first phone. So that's what I'm doing right now, turning off the first phone. You may have noticed while I was doing that, the first job, the job that's being taken care of by the third phone, has actually completed. So we have 1 job completed and 1 phone down. Now we're going to have to reschedule the job that phone was working on. So you can see it went back to the job queue and then was immediately rescheduled to the third phone. So now the third phone is taking care of the job that the first phone was doing originally. Just to complicate things further, I throw another job into the mix, and that job is allocated to the second phone, the only phone that is active and idle. Our third phone finishes its task, and then our second phone finishes its task, and we have completed all 3 tasks despite a failure.